Hey folks, this is Vishwas Narayan, and this is Bangalore chapter, which is coming up with a session on AKS, and also Deepak is a part of Mumbai chapter, and also more of the things about him is on the session, so you can explore about him, stalk him on LinkedIn, stalk him on Instagram, stalk him on Twitter, wherever he is, and moreover, like he's an amazing person for reaching out to, and also if you want to learn something new, just reach out to him. He's an amazing guy. I welcome Deepak for the session. Thank you so much, bro, for giving this session. And before giving him the stage, I would just love to take a note on our community because we are doing a lot, and I hope you guys join us and just celebrate the learning that we just want to give. So anytime that you just log into our website, if there is a session which is there, just hop in for that session. Like just get to know. Okay, if you click on that, there is going to be a session which will be running, and everything will be there. And you guys have to just do that. Like that's what it is all about. And a lot of achievement, 10,000 plus member, 100 plus cities. Organizers are pretty good, and also speakers are pretty good in our side and whatnot. So there are a lot of upcoming events, by the way. And today evening we have open source one-on-one from 7 to 8. And also developing security compliances is also yet to be done, and DAX also doing. And this is the present event that's going on right now. And also there are hundreds of places where you can join from, and there are partnering communities as well. So do stock them up. Just get to know. Okay, this is what we want to know, and what can be offer from that side. And that's what it's going to help you a lot. And as well as that, we have all our past sessions listed out here, so just go and watch them and think about it, because we are all having such kind of an infrastructure for you. So just utilize it as good as possible. And also list of organizers, here's Deepak Pal, and there are a lot of amazing speakers as well, so just go talk to them and just get it done. So that's it from my side, folks. Over to you, Deepak. Thank you so much for giving this session.
Thanks, Vishwas. Thanks so much for inviting me on the stage, and thank you everyone who are joining us. So, good morning, good evening from where you are joining. And I'm really excited to deliver this session because it's my session like on the Azure Kubernetes Service. And if you talk about Azure Kubernetes Service, it's a well-known, cluster management, container management service from the Microsoft. I mean, if you all know that Microsoft Azure is a big public cloud, and we all are using somehow in our daily developments. So I'm just going to present my screen. Just let me know once it's visible, and you can give me a thumb in the chat, guys. So before starting, just I would like to just show a little bit about myself. So about me, like I'm working as a software engineer at BNP Paribas. Prior to that, I worked as senior software engineer with ESS, and also I'm a organizer at Azure Developer Community for Mumbai, because Mumbai is my work location, and for Kanpur, and Kanpur is my hometown. And prior to that, I have worked as Microsoft student partner. It's a great, program if you are a student joining us. And I would suggest that you should join Microsoft student partner program, because it's a platform which gives you initial learning exposure to all the Microsoft technologies. You get support, and currently they are also running the Microsoft Learn Ambassador, so you can join. And you can reach out to me like on Twitter and LinkedIn via this. Okay, so now we'll move ahead to the agenda what we have today. So talking about the agenda, first we are going to see that what is like AKS, Azure Kubernetes Service, what are the benefits of Azure Kubernetes Service, and how we can use it, and what are the offerings of Azure Kubernetes Service we are going to get. And then we are going to, because it's a workshop, so we are going to completely deploy our apps. So we are not going to build the app, because the app code is available on the Microsoft GitHub. So we are going to deploy that app. First we will be creating our Kubernetes cluster, and then we are going to choose the deployment options for our pods, which will be like running our application. Then we will be exposing our app to the external network, so that we can access our app from the outside internet, like anyone can access our apps. And after that, we are going to configure a SSL TLS for our apps, because when we are exposing our app to the outside audience, it's necessary that our app is secure and everyone can access the secure app securely. So we are going to configure SSL and TLS, and then we are going to monitor our health of the app. So sometimes if we see that our app growth, app traffic has grown, and then we are going to monitor that how the apps is performing. We don't want that there is any downtime when the traffic is high and then people explore slowness, or they don't we don't want that user expect that the app is unavailable. So we are going to monitor, and then we will be scaling our application in the Azure Kubernetes cluster itself. So this is the agenda which we are going to do today, and it's all mostly going to be a hands-on, so we'll be doing that. So this is the application architecture which we are going to build today. So when I talk about the architecture, you see that on the top of on the number one section we have Azure Kubernetes Service. Okay, so Azure Kubernetes Service, if you talk about, it's a kind of managed container orchestration service from the Azure, Microsoft Azure, and it's all managed. So it's fully managed. We have to just ensure that they manage the nodes, that worker nodes on which our app will be running. So we don't have to manage our whole OS upgrades, or there is any security patching. It's all being managed by Microsoft Azure Cloud. So on the application, we have Azure Kubernetes Service on the first, and then we are going to create Azure Container Registry. So Azure Container Registry is nothing but it's a kind of hub where we are storing our images of images of the container application. So it's similar to Docker Hub. Like if we have worked about Docker Hub, so that there also we can store our container images. So in the same way, Azure Container Registry is nothing but it's same in the same of Docker Hub. So it's just that it's a we can create a public images in our Azure Container Registry. So we'll be creating that Azure Container Registry, and then if you see, we are going to create our app. So ratings app will be there. We are going so it's going to be a rating app. Like we are going to deploy our app in which users can give ratings about some fruits and all. So if you see the architecture of the ratings app, we have first MongoDB on the backside, which will be storing the data of all the our ratings and everything. So to connect this database, we are going to call this with the API. So we'll be deploying the ratings API so that we can communicate with the database. And over that, we will be deploying ratings web app. So that will be the front end, and this front end will be communicating to the outer world. So for to communicate it, to expose it to the outside environment, we are going to create an Ingress. Ingress is nothing but it's like a method via which we can expose our app to the outside audience. We it's rules where we define our IP addresses, and through which we can audience or customers can access our app. So if you see that on the Ingress, and then we are going to use the certificate manager. So certificate manager, it's like we need to secure our app. So for that, we will be using the set manager, and in the set manager, we are going to certificate authority. Let's encrypt. It's a non-profit organization with just issue certificates. We are going to see that how this issue certificates. And after that, we are going to see the Azure Monitor. Like if you see the architecture, there is Azure Monitor. So we will be seeing that how we are going to monitor the application, how's the performance of our application is going on. And if there is a huge traffic, and we see that there are resources which are exhausting, so then we are going to auto scale, and we are going to use a method to so that our app can auto scale. So this is the whole architecture which we are going to build in today's workshop. So moving on, so let's start with what is Azure Kubernetes Service. So as I've told that Azure Kubernetes Service is a like managed container orchestration service based on the open source Kubernetes. We all have heard in nowadays like Kubernetes, it's the open source container management system, and Kubernetes originally developed by Google, and later on it's became open source. So now like if we talk about AKS, Azure Kubernetes Service, it's a managed a container orchestration service based on the same Kubernetes system which is available on the Microsoft Azure public cloud. So anyone like any organizations, if they see that they are like they have the huge workloads and they don't want to take the ownership of like they don't want to manage their scaling, or when the traffic goes down they don't want to descale the applications. So it's all managed by like in Azure Kubernetes Service. They can automatically define the rules, they can create manifest to which will just do the working for organization, like it will be deploying if there is a huge traffic. If there is no less traffic, then the pods will be auto descaled, and it all will be managing the containers. Okay, so this is about like what is AKS. So this was the basic AKS. Now before like why we need AKS, so I'm going to talk about the container, like why. So what is container? So since the software evolution, initially we used to have a monolithic applications in which like all the whole application was packaged in a single entity. So that was the monolith application architecture. But since nowadays we see that we don't want our audience to we don't want that okay, if there is one failure in a one service, so we don't want that the whole application goes down. So keeping that in mind, we now the like we organizations are moving to the microservices architecture. So microservice architecture is like to implement that. We are going to break our applications in different parts. So in different parts, like we are going to like if you take about e-commerce application, there will be one container for the order inventory, and then second will be which will be managing the order system, and then the third container which will be managing the user access. So we don't want that that whole application in a single package. So to keep that in mind, we the organization are adapting containers. So container is nothing but it's a atomic unit, like for packaging our code and dependencies and configurations, everything in a single unit. So it's like if you see the architecture of a container, like we have infrastructure, then host operating system, and above that we just install a Docker engine, which is like a Docker. We are not going to talk about Docker, but Docker is the like container management system. So container in, so on the Docker we can run multiple containers. If you see like container A, B, C, so these are apps, and these are all running on the different apps containers. So that's what so container. So this is like and from the container perspective, like if you see that application deployment delivery, it's become really easier nowadays, because initially what happens when the monolithic application architecture was there, we used to develop the whole code and then package it in single, and then used to deploy it. And if there is anything goes wrong, then the whole like downtime was used to big. So nowadays, like we are just developing our app and packaging it in a single container, and we are just pushing it to the using the CI/CD applications. We are just pushing it to the production, so that user don't have to face the downtime, or our application will be up all the time. So now like so after it became like container came, so there is like when currently in a like when you have a huge organization, so it's not that like there you will be managing 2 containers or 10 containers. There will be hundreds of containers, and when there will be hundreds of containers, then it will become like slightly different for you to manage it all auto like manually. So to avoid that, like you don't need to take the headache of like managing hundreds of containers on your own manually. So for that, like Google, they have been using this, open source Kubernetes since a long time, but they made it public in the 2014. And since then, all organizations are adopting the Kubernetes. So Kubernetes is the container orchestration management. So it's like a way for automating our deployment and scaling management containerized applications. So it just like it's abstract away our all the complex works which we had to do in manually. Like we, if we there is no Kubernetes, then we will have to manage the containers manually. So Kubernetes just simplifies our that task, that it manages all the deployment, automation of deployment, scaling, management of containers applications. So that's the Kubernetes for us. Now we are going to talk about like what is AKS working, how it works. So as we have I talked that AKS is a fully managed service on the Azure cloud. So it's a managed cloud, since so you don't need to manage the control pan. If you see the working in the diagram in the left hand, that is control plane, and it's all fully managed by Microsoft. So you don't need to set up the Kubernetes management and control plane, and you just need to run your application on the nodes. So whatever you, if you see that the application traffic is increasing, you can add multiple nodes. Okay, so what you are going to manage in the AKS, you are just going to manage your nodes. So you can add multiple nodes, as many nodes as you want. So you can add that, and you don't have to take the headache. So if you see the in working, we have API server, we have etcd, that is the registry, and we have controller management. So it's all communicating with. So when you issue a command to the AKS, controller, it checks the which nodes are available, and as per the nodes availability, it assigns that okay, on this node this pod is going to deploy. So customer manage, this all the left hand side, it's all managed by Azure. You don't have to manage everything. And also the best part is Azure doesn't charge for your Kubernetes. You just need to pay for the customer managed nodes. Okay, so in the node section, if you see, we have the kubelet is communication channel which is going to communicate with your control plane and the nodes. And we have container runtime which is responsible for running your containers. And then qproxy is nothing but it's it's used for assigning the IP addresses. So managing the IP, exposing it to the, like if there is some huge traffic, and managing how to assign IPs to multiple pods, it's going to done via qproxy. So this is how the working of AKS works. And now we'll be talking about like what AKS offers us. So if we see that it offers end-to-end deployment, scalability, availability. And if we talk about end-to-end deployment, what it does mean, so it means that we have to just use the platform, and we can just focus on the development of our application, and we can directly deploy on, we just need to create a manifest file. Via that, we are just going to deploy it uh, on the portal, and it will be become available to the customers. And scalability means like when the you like your audience, your customer base is growing, and you start facing a huge traffic on your app. So there comes the scalability. So you don't want that the traffic is there, and you don't want that your app goes down or customers face slowness. So to avoid that, we have the scalability. AKS offers like auto scaling of the containers, and then availability. So when we talk about availability means we don't want that there is any unavailability of our apps, that due to some uh, due to updates or something like OS updates, or there is a maintenance, we don't want that our app goes down. So Kubernetes, like AKS this offers that our app is most of the time like 100% available. So that's the offering of AKS. And if we talk about the architecture of AKS, how the architecture, like how it's working. So if you see that on the top of like AKS, we have front end, we have back end, and the Kubernetes, we on the like AKS system, we have created a cluster, and it all being managed via like we can create a role-based access policy, so that I mean who we don't want, if we multiple teams are going to access our cluster, so we can create a RBAC role, that is role-based access control. And we have monitor policies, like how we can monitor our apps. And out of that, like out of AKS, we have the Azure load balancer, which is going to balance the, like if the traffic goes down, and how many pods we need to be available. So it's all being done via the Azure load balancer. And then we have, out of that, we have client apps. So if we talk about like CI, this is like how the this we are pulling or pushing our apps. So you see that we are using CI/CD. With CI/CD, we can directly push our apps to the container registry, and it will be become available. So if we talk about like what are the components of AKS, I mean architecture of AKS in, so Kubernetes cluster. So if you see the cluster running your workloads deployed on AKS, so I mean Kubernetes cluster is nothing but it's a workload to it's I mean running your workloads. And then we have virtual network. So AKS creates a virtual network, I mean which agent nodes can be deployed on. And Ingress, as I talked earlier, that Ingress is nothing but it provides a path to HTTP or HTTPS, so that we can access our app from the outside. And Azure Load Balancer creates, I mean, when the Ingress controller is implemented, and we can use route the incoming traffic to Ingress. And see, if we when we have our app, so we don't want to like the data, because containers don't have the storage facility. And if the container dies, it dies. I mean there is no data, there is no state remains. So we don't want that. If the container died, and we don't want to lose our data, so for that we are going to map the external data source storage, so that it will be accessible from the container. And we are going to map these external data sources to our containers. And in the same way, so how this works, so kubelet, the working of AKS, if we talk about, so kubelet is the main responsible function, like a Kubernetes agent that processes the orchestration request from the control plane and scheduling the running of requested container. So kubelet is going to take the request, and it's going to send the request to the nodes, and like it's going to check which nodes are available on the resources basis. And it's going to assign the nodes, and that okay, you need to create this many of pods. And then kubeproxy, this handles the virtual networking on each node. So kubeproxy, like I talked, like so when we have multiple nodes and we want to like communicate with each node, so kubeproxy is going to assign the IP addresses for our each nodes. And container runtime, which allows containerized applications to run and interact with additional resources such as virtual network and storage. So this is the working. Now let's see. I'm going to talk about like what we are going to app, what we are going to do in the app. So okay. Uh, so okay. Okay. So I'm going to share a link of the app, like the workshop which we are going to develop. I'm going to share a link of the notepad notebook which I have created, so that you can follow with along with us. And I'm going to create follow this notebook itself to start the workshop. So just a minute, I'm going to start. Uh, okay. So if you log into the portal on the Azure, we are going to perform the like all the commands via the Azure Cloud CLI based. You can create clusters from the portal itself. I'm going to show it later, but initially I'm going to use the Azure CLI. So I've shared the link with you all, in which like in the commands are there. So first we are going to set up the resource sections. Like if you see in this values, so I will like created a variable region name. So I'm going to assign the region East US, and I'm going to give the resource group name AKS workshop, and I'm going to create a subnet name for the like a virtual network AKS subnet, and VNet name AKS VNet. So I've created these variables so that in the when I create the resources, this variable will be used. So the command to create the Azure resource, if you see, the command is simply ag group create. So it's going to create a resource group. I'm going to pass the resource group name. It's going to fetch the resource group from this AKS workshop because I have initialized this variable. And then it's going to fetch the location, like because we need to define the location in which we are going to create the group. So the region name is East US from the usual variable. So if I press this, it's going to create, but I've already created that. So if you see that, okay, this has created AKS workshop resource group. And if you see the output is succeeded. So in the same, if you see, I can show you in the next tab that the resource group is created, okay. And now we are going to configure networking. So to configure networking, we are going to use this command. So if you see the AG network, so AG, I mean, if you have installed the AG CLI on your local PC, you can run these commands, or you can directly run these commands on the cloud itself, on the portal itself. So you just need to run this button and the cloud shell will open, and you can execute. So it's going, I mean, it will be better if you all going to perform these commands with me. And if you face an issue, I mean, we can look into the issues and we can rectify. So in that way, you are going to, I mean, get the most of the benefits from this. So if you see that this has created the virtual network, I mean, VNet. So when I run this command, which is like networking, now we are going to retrieve this subnet ID because we are going, when we will be creating a cluster, so we are going to use this which we just created. So if you see the command, this command like AG network vnet so command is going to get us the value, and if we print this value, we can see that subnet ID. Okay, so we can see that this is the value is we can get the value this. Okay, we have got this value. So in this way we have now the subnet. Okay, now we are going to create the AKS cluster. So in the AKS cluster, if you see the code, we are going to first get the latest version, like which are the non-preview version. So if you see the command, it's showing that AG AKS get version. So it's going to get the versions which are available on the Azure public cloud and which are not in the preview section, I mean preview stage. So we are going to fetch the version of the latest stable release which is available. So when I run this, it is going to give us the version, available version. So if I now print the value of the version which I have got, so you can see that 1.21.2. So it is the stable version which is available on the Microsoft Azure. Now, since we have got the version, so we are just going to create a AKS cluster. So to create a cluster, we just want to give a unique name. So I'm going to use this variable AKS cluster name, and the value is AKS workshop dash $random, and this random is going to give us some random numbers so that the cluster name will be unique. Okay. And so if we can print it out, like we can see what name we have got. So if you print this AKS cluster name, so okay, I forgot to add the dollar AKS cluster name. So you can see I've got the name AKS workshop 20151. Okay, so this is the unique name, and with this cluster name I'm going to create a cluster. So to create a cluster, I'm going to execute this command, and in this command, if you see, there are resource group which I already created, and the name of the cluster which I just got the name from the above AKS workshop random. And then I'm going to VM set type. So VM set type is nothing but the virtual machine type, like what type of machine set we am going to use. So if you see, the value is virtual machine scale set. So I'm using virtual machine scale set because if the, I mean, later on when we want to scale out our application so that we can scale easily, so that's why I'm going to use virtual machine scale set. And the initial node count, I'm going to give the node count as 2, like I mean, on the base, on the production environment, we generally use a higher node count on the basis of like how the app is going to perform and what level of app is available. So for this demo purpose, I have just used node count 2, and then I've used load balancer SQ. So I'm using the standard protocol for the load balancer. Region name, the region name which I earlier assigned at East US, and Kubernetes version which I just fetched at 1.2.1.2. And for network plugin, I'm going to default Azure network, which is available in the Azure. And subnet ID, I've like created the subnet ID initially, so we can we have the value of subnet ID. And if you see the service CIDR, so this is like a service CIDR. We are defining the IP range, so we don't want that there is any IP range. I mean, we just it will be difficult for us to get the IP ranges. So we just want that, okay, the Q proxy which creates the IPs, this should be starting from this range itself. Okay, so we are going to define this IP range, and then we have DNS range. We are going to similarly define the IP in this, and we are going to use the Docker bridge address. I mean, Docker bridge address is the connecting bridge for the connection of protocols. Like via this, we can communicate within the within containers, and then we are going to generate SSH keys so that we can communicate with this cluster. Okay, so I'm going to run this command. So it will create a new cluster for us, and we can see it. Okay, it's going to take a little bit time, and meanwhile you can it's running. I mean, you can, I'm just going to open the portal where I'm just going to show you. If you see that I have got this AKS workshop resource group, which is we have just created, and inside this resource group, this is the Kubernetes cluster which I created earlier. And once this generates, it's going to generate a new cluster, Kubernetes cluster with this name. So we will be getting this name, new cluster, in our resource group itself. In the meantime, I'm going to see if there are any questions. Please, okay, presentation. Do you have PPT? Yes, so I do have the PPT, and I'm going to share it you all later on. And can you please note the link in the comment section? Yeah, so I have pasted the link of the note, so I guess that's answers your question. And you can access that notebook. It's on the read-only mode, so you can get all the commands, and you can run those commands along with me. And I think that's okay. So no further questions. So I'm going to see. So the cluster it's still running. It's still creating our cluster in the workshop. Okay. So now if you see, I can see there is a cluster. I'm just going to start it. Okay. So now you can see that I have got this cluster created in my Azure portal. Okay, AKS workshop 20151. Okay, but here it's still running, but in all the processing it's being done. So I mean, it's not yet fully available, but I can see in the Azure portal that this AKS workshop Kubernetes service cluster is being available. So it's still running. The command is still running. Once it's execute successfully, I'm going to get the response like, okay, it's successfully executed. So it's just going to take a few minutes to execute, and then we are good to go. Okay, so it's still executing the command. Meanwhile, do let me know if you all can access the notebook, and if you have any, like if you are performing these commands along with me. So if you are facing any issue or you have like any difficulty executing these commands, do ping me in the chat section so that if I can help you. Okay. So now you can see the output. Like I mean, the cluster is created and we have got the full output, and that okay running and everything is okay. So by this we have now cluster our cluster. This cluster is ready to. I mean, it's successfully executed. Okay. So now what I'm going to do is I'm going to test the connectivity of my cluster. So to test the connectivity by using kubectl. So kubectl is like it's a tool which helps us to execute our command. So first to check the connectivity, I'm going to issue this command to get the credentials of the my cluster. So if you see, I'm going to, so it's saying that it has like my credentials are merged in this home directory .cube./config. So with the credentials, because in the earlier command, if you see in that I created a SSH key. With those SSH key, I'm going. So these SSH keys are nothing but like it's a way to securely communicate. So that's why these. I mean, the credentials are now merged in this cube config file, and now I can check the connectivity with the cluster. So if you see that it's going kubectl get nodes, so this command is going to fetch me the nodes which are available in the kubectl. So if you see, I mean in the command, as you see that I passed it in two nodes. So you can see that there are two nodes, AKS node pool 1, 0 and node pool, and the status is ready. Okay, and the age is just 2 minutes 2 minutes 39. So with that, like because I just executed, so these are the node counts. So if you are going to deploy more nodes, I mean if you are going to increase this node count to like 3 or 5 ideally, so in the same way you are going to get those number of nodes in the when you query that kubectl get nodes. So now as you can see, my nodes are ready and the cluster is ready. So and I also connected with the cluster. I've checked the connectivity so I can connect. So now I'm going to create a namespace. So namespace, in if we talk about namespace is a like an entity. So that because when we are working with Kubernetes and we will be having so many resources, I mean in the container and all. So like it's namespace is nothing but it's a kind of naming for our like ratings app. Okay. So in ratings app, we want to uniquely identify that okay, all these containers are enclosed in this namespace. Like for the ratings app, if there are 10 containers and there is database at the backend and the API, so we want that all those should be clubbed into a namespace. All those should be named as a namespace. So that's the namespace. So I'm going to create a namespace. So first, before creating a namespace, I'm going to check if there are any namespace available. So if you see, the default namespaces like kube node lease, kube public, and kube system. So these are the namespace. And if you are not going to give any name, I mean, if you are not going to create a namespace, then Kubernetes is, AKS automatically gives assign the namespace. Okay. So to avoid automatic assign, I'm going to create a namespace. Okay. So to create a namespace, there is a just simple command that says like kubectl create namespace ratings app. So as you can see, the output is namespace ratings app created. So now we have created our namespace, and in this name itself, namespace, I'm going to like deploy our database, the ratings API for connecting the database, and the front end of the ratings app. So this is the namespace. Now let's because let's create a container registry. So container registry, as I explained earlier, that container, it's a kind of repository where we in which we are going to store our images. So Images like our container images. So I mean, if you have heard about Docker Hub, so in Docker Hub also we can store our container registry, container images. In the same way, we are going to create a container registry in the Azure cloud, so that I mean it will be a private repositories for us, and we don't want to expose our images to the public. So to do that, I have just used the first ACR name, ACR like Azure Container Registry name. So I'm going to give it ACR and then a random name, a random number. So with this, if you print this, I have got what name I have got with this ACR name. Okay. So you can see I have got ACR 27379. So with this name, I'm going to create a container registry in the Azure cloud. Okay. So to create a container registry, there is a simple command, that is ACR create, and the resource group I'm going to I don't want to create I mean these registries and everything in different resources. So because after the workshop I want to clean up all the resources, so that I mean that's why I'm creating all these in a single resource group, so that I'll just have to remove that resource group and the cleanup process will be done. So for that, like resource group, I'm using the same resource group, and location, region name, like I assign this variable the initial name, and I'm going to give the name, ACR name, and SKU, and that is standard. Okay. So I'm executing this command. It will create Azure Container Registry. It will take just few minutes to create. Okay. So you can see I've got the output that okay, it's created, and I can show you like where this registries are created. So if I go to the AKS workshop resource group, you can see a new container registry will be created. Okay, I guess I have got some. I'm going to refresh this, and you can see I have got this container. The name was 27379. So this container registry is created. So you can create as many number of container registries you want in your public cloud, I mean Azure clouds. Okay. So you can see that this container registry is created. So now we have like AKS cluster, our cluster is ready, and we have also created a container registry. So now we'll move to the deployment of our application. Okay. So to deploy the applications, we will be building images like container images first, and I'm going to use the images from the Microsoft like GitHub account, Microsoft Learn. So the ratings API, if you see the GitHub clone, I'm using this. So the source code is available in this HTTP GitHub Microsoft GitHub account and MS Learn AKS workshop rating API.git. So I'm going to fetch that, and what it's giving me error that already exists. Okay, it's not empty. So if I just use this command, so if you see that, okay, I have already created this, fetched this, clone this repo earlier in my Cloud Shell directory. That's why it's saying that it's already exist and it's not empty directory. So not an issue. I mean, it's already for you all. It's not available, then it will be cloned in your Cloud Shell repository. Okay. Now I'm just going to move to that repo, and I'm going to just show you some contents of this app. So if you see, there is app.js. So this app is built on Node.js, And what is the main part is Docker file. So I'm going to show you the content of Docker file. Docker file is the file responsible for containerization of our application. So this is the main file which when we will be building our application, it's going to look for. So when you are going to containerize your applications, you must have a Docker file with this name, Docker file. And in that, if you see that we are going like from Node.js, Node 13.5 Alpine, so it's going to take this image, OS image, and then work directory, we have defined this, and then run apk command. So this is for like OS update, and then installing the Python some libraries. And this is all like all the code for the source code is going to take from app.js. So if you see the copy package.json, so we have the package.json file. It's going to copy this file from our source code to the container. Then it's going to run the npm is the node package manager. So because it's a node.js application, we will be installing the node package manager. Okay, so all these commands we have defined in the Docker file. And to build this file, I'm just going to issue this command which says agacr build resource group. So the resource group name and container registry name which I just created, and image I'm going to give a name like ratings API version 1. So because so in later on and in real like prod environments, when we assign the versions like version 1 or staging or UAT, so in that way we can just assign these versions. Okay, so if I execute this command, you can see it's going to build my image. You need to make sure the dot at the last, if you see this dot means it's going to look for the Docker file from your current directory. So if you have the Docker file in different directory, you need to mention that path. So if you haven't mentioned any path, it's going to look for the Docker file in the same directory. So as you can see, it's building, and it's going to push the image in my container registry. Okay, so we'll see. So if you see, the output is like okay, the image, and it's successfully pushed. Okay, so if I'm going to show you in my container registry, I'll just need to refresh this, and you can see the image will be available. Okay, so I've done the two seven. If you see, it's also giving me the registry ID like ACR 27379. So if I go to 2737 container registry, I can see the repositories. Okay, and in the repository I can see the ratings API image which I just pushed. Okay, so this is like our ratings API image is pushed in the container registry, and later on when we will be deploying our app, we are going to use this image. We are going to fetch our image from this container registry itself. Okay, so now we have pushed our API image, and now I'm going to build the web image. Web image is the front end image. Okay, so I'm going back to the main directory, and as I earlier shows that I've also uh, cloned the web app source code also. So if you run this command git clone web app, so for you it will be cloned, but for me, as you can see, that it's already available, so it's not going to clone again because it's already existing in the same directory. So I'm just going to move to this directory. Okay, and in the same way, if you see this directory has the same code base. Like we have a Docker file, we have our source code. I mean, in source folder we have our all the front end code. So in that same file, so what we need here also, we just need the Docker file to build the front end and push the containerized application to the container. So I'm just going to build again for this web app, and you can see I have given the name image ratings web version 1. Okay, earlier that was the API ratings API, which is going to communicate with the database and between the app, and now this is the front end. So I've given the name ratings web version 1. Okay, so once this is done, this will be available in this repository section, and we can also check this via this command. If you see verify the images, so ACR repository list. So I'm going to execute this command also, and it's going to give us the same images which are available in the container registry once this is done. Okay, so if you see, it's still building all the node. It's a node JS application, so it's building. Okay, once this is done, the image will be successfully pushed to the repository. If you are following along with me, do share, I mean, at what step you guys are, and if you are facing any issues, just ping in the chat section. And if you are going to follow along, I mean, later on, that's also fine. Okay. So it's just taking a little bit time. Just, I mean, it's building the whole application. Okay. So it's building. So all these things, I mean, a lot of commands which I'm like creating. I just want to tell you that this creation of container you can directly create on this from the portal itself. But if you are like I mean commands guy, then you would prefer the commands, executing the commands over the CLI. I mean bash. So now you can see that it's preparing to push our image to the registry. Okay. So I'm going to just refresh this so that you all can see once it will be pushed. So you can see it's successful. So if you see that my ratings web image is available in the registry now. So as I was telling that you can also verify this, which are images available in my container registry. You can just execute this command AGACR repository list and name. We have just passed the container registry name and output in a table format. So you can see the results with ratings API. So if you when you are working for organization, you will be having lot of images like hundreds, or I mean, so you can that's why you will need to define the names to I mean each and every image. via which you can just identify, okay, this what this image is ratings API, ratings web, or if there are any like front end, back end, you can give that in that way also the names to the images. Okay, and now I'm just going to update the AKS cluster so that this can like I can communicate to my this container registry. Okay, so I'm going back to the main directory, and if I've executed AKS update command and AKS cluster name, like because I'm going to use this repository, I mean images in my this Kubernetes cluster. So to communicate, to authenticate these registries, I have executed this command. Okay, update. So it's going to update our container, I mean cluster with my container registry. So if you see the command attach ACR, so it's attaching this container repository to my Azure Kubernetes cluster. Okay, so it's updating. It's going to take just a few minutes. So if you see the commands, these commands are very simple. I mean, you can also in the Google, if you search for AGKS commands for all the CLI, which also you will get a page. I can show you that also AGKS commands, and there are, I mean, all the commands which are listed. Okay, so if you see in this page, you can see all the commands which are available. Okay, so now our ACR is like container registry is attached to my cluster, Kubernetes cluster, and since now container registry, I mean container registry is attached, now I can start deploying our apps to the Kubernetes cluster. So I'm because at our in our application I'm using the MongoDB at the backend. So to use that MongoDB, I mean I'm going to use Helm repository. So if you have opened the notebook which I have shared in the second page, you can see the deploy MongoDB ratings API and ratings frontend. So in that, first we are going to add the Helm Bitnami repository. So it's nothing but it's giving it's a way. I mean it's a repository of all the like MongoDB and all other images. So it's a repository. So I'm going to execute this. Okay. So Helm client is already added in the Cloud Shell, but if you are executing this command in your local PC Azure CLI, then you will need to add the Helm client in your Azure terminal. If you are using on Mac, you need to add the Helm client in your terminal, or if you are on Linux, you will need to add this the same. Okay, so you can see I have added this repository, Bitnami repository, and this repository is going to give me the images of MongoDB, and because which is I'm going to use in our application. So if you see this now, I can also execute this command first. Actually, search. So if we want to look at the images which are available, if you see there are hundreds of images available. Okay, so I mean there are so many images available like common data flow. So these all are like MariaDB, MongoDB, MySQL. So if you are going to planning like MySQL, you can use that image also from this. So when I search there, these are the images, Tomcat, web server. I mean these all images available in this. That's why I use this Helm repository. Now I'm going to create the MongoDB image. So if you see that I'm going to install ratings MongoDB, and I'm going to give the namespace the same because I'm going to create this in the same namespace, so that there will be no issue in the later on stage when we are cleaning up. And there is one major point here in this command. If you see, it's saying that set auth username and auth password and auth.database. So because when we are dealing with database, you all know that we need to have a username to connect with the database and a password and a database name. So in this application, if you are following along, you the application is going to look for ratings DB name. So that's why I've given that name. And the username I've assigned given it name as admin. If you want to give any other name, you can give it name, your name, and in the same way you can give the password, whatever password you want to give. So this command is going to install the MongoDB in my name is ratings app namespace. Okay, with the username admin and the password I've simplified, given this simple password, but this kind of password we generally don't prefer in our prod environments. So you can see this has created, install the MongoDB. Okay, now let's create a secret, because in our prod environment or live environments, we don't want to write our these secrets, that username or password, in the manifest files or something. So Kubernetes has a concept of creating a secret. So secret is nothing but, if you heard about CyberArk or Key Vault system, so in the same way, it's kubectl. Kubernetes has its a secret management uh, option where you can create secrets for your applications, and later on you just need to refer with this variable names. You don't need to pass the you don't need to hard code the username and password in the application. Okay, so I have created a secret. The command is kubectl create secret generic mongo secret. So I'm given the name mongo secret, and this secret is all I'm also creating in the same namespace ratings app. And from literal, so if you see mongo connection, MongoDB the name and the password, like admin and password. So MongoDB, this the database, and this username I've given, and the password. If you remember in earlier statement, I gave this username and the same this password. So you need to change these values if you are giving different username and password. Okay, so now the secret is created, and we can run this command describe to see the secret. Okay, so we can view. So you can see that, okay, when we just run the kubectl describe secret mongo secret command, so you can see the namespace is same. Name is mongo secret, and it's created under the namespace ratings app, and I haven't given any label or annotation. And you can see the data. It's mongo connection, and we can't see the values here. So we will be referring this variable itself to get the values of username and password when accessing the application. Now let's deploy the ratings API first. The API, since we have now installed the database, so to communicate with the database, as we have seen in our application architecture, we will be having a API which will be communicating between the database and the front-end app. So let's deploy the ratings API. So to deploy that, I'm going to create a manifest file, and to create that manifest file, you just need to write code ratings API deployment. I'm giving this name ratings API deployment.yaml manifest file name, and code is the abbreviation, like it's opens a nice interactive editor in the cell itself. So like if you seen VS Code, so it's based on that itself, a nice code editor in Cloud Cell itself. Okay, so in this manifest file, I'm going to paste these commands, and I'm going to discuss these like little bit what these values are in this file. So if you see API version, so all the YAML file, I mean YAML file is like nowadays in every manifest when we are declarative using the manifest file to deploy or say create services, we are defining the API version. So we are defining apps version 1. More if you want to like what values you can give in API version, you can just Google it, and you will get all the list of values which you can pass in the API version. And you can see the kind is I'm giving the kind of deployment, and if there is like any service, so I can give the value service in the kind, and I'm giving the name ratings API. So this is the name which I'm going to give, I mean for the API communication. And if you talk about the labels, there are other things. And if you see here image, so from where this is important, because I have just created the ACR image, I mean so this image I created earlier, so now I don't have this image, because if you give a different ACI image, I mean container registry name, so it's going to look for that image in that container registry. So you need to be careful while giving the container registry name. I mean, if you see, when I was pushing the images to the container registry, we got this kind of like response that okay, this is. So currently if you see my current API is which I linked was this one. Okay, so I'm going to change my name to this in the container registry, so that it should look for the images in this container registry, not in this what I created earlier. Okay, so the name is ACR27379. ACR27379. Okay, and all other things like the container port, so the application will be listening to this port. Image pull policy, like always means, it means that if there is any image new image available, so it's going to always, I mean pull from the container registry. So now I'm going to just save it and close the editor. And once to deploy this, I'm just going to use the command kubectl apply command. So kubectl apply namespace ratings f ratings API deployment. I have passed this the same name, so you can see the deployment.apps ratings API is created. So my ratings API deployment is succeeded. Okay, and you can watch the pods which are rolling out, because I have just done a deployment. So you can see which pods are available. So you can see that okay, ratings API 1/1 it's ready and the status is running. Okay, so we can see that okay, my deployment is successfully created and my pods are available in the cluster, and it's in the running state. And to come out from the watch, just press the Control C command so that you can come out from the watch state. Okay, I can increase the font. Yeah, I can zoom a little bit. Oh, sorry. Okay, I hope now it's more visible. Okay, and since we can see, so status of deployment, to check the status of deployment, we can see. Okay, we have just seen that kubectl, when we executed this command, name is like get pods, so it gave us the list of pods and the status that running. and we can see the status of our deployment. So you see that ratings API and it's available. So it means that our deployment of the ratings API app is successful. Okay. Now let's create a service, because when our API is going to communicate to the database, we will need a service to communicate from the database and the API. So for that, I'm going to create a API service. Okay. So in the same way, code ratings API service.yaml, this code is going to open an interactive window, and like we have seen in the VS Code editor. So it's a editor code editor window, and I'm just going to define the values. Like I'm going to explain a little bit here. If you see, if you remember in earlier when I was doing the deployment, I defined the kind was as deployment. Okay, and now since I'm creating a service, so I'm defining the kind as service. Okay, and I'm giving the name ratings API same and selector, and the ports, if you see, it's going to communicate on the 80 port and via the TCP protocol. Okay, and type is cluster IP. Cluster IP is like it's a kind of assigning the IPs communication. I mean, cluster IP it gives us the availability so that our containers can communicate internally, and it doesn't expose the IPs to external sources. So I've defined the type as cluster IP. Now again save it and close the editor, and to apply this code, service, I just need to execute this kubectl apply command, and it will just deploy this service. So if you see the command kubectl, the namespace same, and I just passed the name ratings API service, and you can see the service is created. So we have now, till now, the MongoDB is available, and we have deployed our ratings API, and we have created a service to communicate to the database and API. Now let's check the status of the service. Okay. So you can see ratings API, and I've got this type as cluster and the internal IP. And this cluster IP, if you remember when we were creating the cluster, we defined the range, IP ranges. So it's picking the IP ranges from that range itself. Okay. And now we are going to validate, because so that services can be served. Okay. So if you see, endpoints are available. Okay. Now till now, as you have seen, that we have database, we have API to communicate from between the database and the app. So let's now deploy our front end application. So I'm going to create a new deployment file, code ratings web deployment.yaml, the manifest file, and to write the instructions like, okay, which web image is it's going to fetch and everything. So just I'm going to paste this code, and I'm going to talk about this code. So if you see here again, as earlier we've seen that kind was deployment when we were deploying the ratings API, and in that we gave the name ratings API, and this is the front end application. So I'm passing the name ratings web. Okay. So name, and in the same way I just need to change the image location container registry, because now I have a container registry, this one. So I'm going to just change this because I've already showed you the images which are available. I pushed my API image and ratings web image in this container registry. So I need to pass the same name, ACR 27379 container registry URL, and the name ratings web and version 1. So when we, like, it's very important, like as I showed you that when we were pushing images, we gave this name, right? So after later stages, whenever like there is any update in our app, so we push the images with version 1.0 or version 1.2. So in that way we can identify, okay, that this is the latest version of our image. And then in the same way we have container port, the application like 8080, this is the port in which application will be running. Okay, so all other things are like environment and resources, like how much CPU I'm giving and what memory I'm assigning to this deployment. So we can define so that it doesn't exhaust our resources. And when if the traffic goes on, I mean if traffic increases, so we'll see that, okay, the CPU these are exhausting, then the AKS will see the health and it will auto scale. So auto scale we are going to see it in the later part. Okay, so I'm going to save it and I'm going to apply this deployment. So the same command kubectl apply namespace, the same namespace, and the name I'm passing the file name ratings web. So you see there is a error what it's giving me, kubectl apply. Okay, it's saying that the ratings web deployment.yam does not exist because I didn't give the full name. It's the name YAML. Okay, so you need to pass the full name because it didn't find that file. That's why it gave error. So now you can see deployment apps ratings web is created successfully. So we have deployed, and now similarly again we will be watching that, okay, for the web app how the pods are rolling out. So you can see the state is currently container creating. Okay, and it's coming out, I mean the container creating running. So as soon it depends, I mean on the speed, like it's managed by our Kubernetes cluster. So it's container creating and then this container is ready. Okay, so let's come out of this watch section, control C, and we can see the status of our deployment kubectl get deployment. So you can see the ratings web is available now. Okay, so now ratings web app is available. So now till now we have done like install our database is ready. We have created ratings API to communicate between database and front end. We have also deployed the web front end, and now let's create a service for the front end also. So to create a service for the front end, again create a manifest file ratings web service.yaml, and in the service file I'm again passing this code which says that, okay, API version v1 kind is at service, the name ratings web, and is app will be selected, like select app. I'm passing the name that which app it needs to select. So ratings web, which is we just see that it's available, and the port is 80 and the target, that is application port, is 8080. Okay, so okay, I'm just pasting this code, save it and exit the code editor, and again apply this service. So if you just apply the service, you can see service ratings web is created. Okay, so this is available now. Now let's check this service. So if I check this status of the service, so you can see that initially it gave us that external IP was pending, and now with the load balancer it gave us a external IP. It just took us few minutes, few seconds to give us external IP, and on this external IP, we can access our application. So if you just use this URL, copy this URL, and on the different app, you just paste this, and we are going to test our application. It should be working. Okay. Okay, so it's, let me pass this as HTTP. Should be what's happening? It's not working. HTTP, and I'm just giving that URL. And here our ratings app is available on the internet. You can see it's available. Okay, start rating. You can rate the, like, okay, 2 rates, 4, 5 rates, and you can submit the ratings. Okay, so on this you can see the app is fully available on the internet. But one thing is, you can see that this is not secure, because we have just deployed and using the external IP load balancer, and we till now we haven't implemented the SSL or TLS, SSL TLS in our website. So that's why if you can see the, it's showing that connection is not secure. Okay, so let's come out of this. Watch, we have just, we will just note down this IP, because we are going to need this in our future. Okay, so to make our application secure, we will need to implement Ingress. So Ingress is nothing but, it exposes routes for HTTP and HTTPS traffic from outside a cluster. Okay, so it defines the rules. So that when we, if anyone tries to access our application from the outside, it passes through the Ingress. So it defines the rules. Okay, so let's go for the creation of the Ingress. So as you've seen that for the app, we created a namespace, ratings app, and under that namespace we created the database, and we created the ratings API, we created the front end. Okay, and now when we are, going to create Ingress controller to run our app securely, we are going to create a new namespace, that is kubectl Ingress. So we have seen that namespace. So namespace, as earlier talked, that namespace is nothing but it's a kind of name to some entities. Like, okay, like in the application, we, in the ratings app namespace, we clubbed all the database, we created API, and in the same way now we are going to create a namespace Ingress, so that our all the application certificates and all those will be managed from this namespace itself. Okay, so to as earlier I used Helm repo to get the image of the MongoDB, and I also executed the search command. So in that search command, we seen that there are so many repositories available for us to use. So from Helm repository itself, I'm going to use Ingress and Nginx repository, image, for to create the Nginx. Okay, so you can see Nginx Ingress Nginx has been added to our repository, and so it's being added in our repo, and I'll just update it to execute this, so that this repository is updated. Okay, So you can see that message successfully got an update from Ingress. If there is any update from the like in the repository, chart repository, so it got updated. And now I'm going to install the Ingress controller. So to install that, we have this command helm install. This command is similar, like if you see earlier, we used that to install the MongoDB. I used helm install MongoDB, and the name MongoDB in the same way, helm install nginx ingress, the image in ingress nginx, and the namespace. I'm creating this in the ingress and controller replica count. So I'm going to create this. Okay. So it's just going to take a little more time to create. And it's going to install that. Okay. Guys, if you are following along, just ping me if you are able to like execute, if you are able to follow the steps or not. So you can see the outputs, like if is enabled, it's created. Okay, you can see the output. And let's check the IP. Okay, what we got. Okay, so you can see nginx ingress controller, I got this external IP from the load balancer. Okay, so this external IP, I'm going to copy it. Okay, and I'm going to reconfigure our previous service like EM manifest files with this to include this ingress. So to do that, I'm just going to edit the ratings web service which I earlier created in while deploying. So I'm just going to edit that. If you see here, the earlier I got the external IP with the load balancer, but now since I've included the ingress, I'm going to use the IP in the using the cluster IP. So I'm going to update this file, and there is only one change. As you can see, in earlier it was load balancer which was giving us external IP, and now I'm going to use my cluster IP which is going to be from the ingress controller, so that our web app is secure. Okay, so this is updated, and since we have already deployed our service, so there is a like you can't update value on a deployed service. So if you want to update the file and redeploy it, so you need to first delete the previous service and then again apply. So I need to just delete the previous service which I created, which I deployed. Okay, so it's deleted, and then I'm just going to rerun the apply command to include this cluster IP segment. Okay, so you can see we have got the response that service ratings web configured. Okay, so we have configured this, and now let's create an ingress resource for the ratings web service. So I'm going to create a resource web ingress, and in that you can see I'm using this script. So in this script you can see the kind is ingress. So for all the, as earlier we have seen till now, that previous kind was deployment, then we have seen a kind of service, and then now it's kind of ingress. So as I told you that you can see all the values which you can pass in API version and kind, and these are the main two fields which you need to define, and for these values you can Google up like what all values are possible in these. And I'm going to give the name ratings web ingress, and annotations is like Kubernetes IO ingress class and Nginx. Okay, and then the service name is ratings web, which we already deployed. And here if there is a change like because we now don't want this app to be accessed from this directly uh, external IP. So here I'm going to update my IP address which I earlier got, this IP. Okay, so I'm going to update this IP, external IP, in this place. Okay, and NIPIO is a DNS name service. It's a free DNS name service you can use. I mean, you can have seen that there are. I mean, if you have your own domain, you can use your own domain name itself. But here I'm using that NIP, so it's a free domain name service which is available. Okay, so let's save it and close the save. Okay, and again we need to apply this. So I'm applying this. Okay, so you see that ingress created. So now we have created the ingress, and now we can test our application with this new domain IP address, so which we gave in the API. So currently we have this. Now I'm going to front end. I've given a name, and I'm going to this use this save external IP which I have, and replace this IP. Okay, just a minute. Okay, and HTTP. So our app will be accessible from this new URL now. It's just loading. Should be up. Okay. So I've seen that service is running. So I just need to, it's taking a bit time to load the application. It should. Okay, it should be up. The application should be up with this new URL. It's taking a bit time to load. I don't know why it's taking this much of time to load the application. Because we have updated that. Let me try in another browser if it's worked or not. This app should be up. Front end. Sorry, I don't know why it's not loading. It's taking a bit time. I don't know why it's not loading in the browser. What it's giving site can't be reached. There is something which so I have applied, and I can test the application, but it's not loading. Okay, so let's see why it's not loading. I mean, it should load. I mean, I've just updated that IP address applied, and I can test it. So it should be up. I don't know. I mean, it should be up. Ideally, after updating the Ingress rule, this app should be up. So I'm going to see it later on. Now, till now, we haven't used any certificate to secure our website SSL and TLS. So to do that, there is a cert manager which we saw in the application architecture. So in the same way, I'm going to create a namespace for the certificate manager, so that all the certificates validation and if there are renewal of certificates, it will be done in the same namespace. So and certificates will be stored in this. So I've created a namespace with the cert manager, and I just need to pull that repository, that Helm repo at JetStack for the certificates. So this is added, and I'm going to update my repository. So you can see earlier we have this repository, then we added this Ingress nginx, and now we have got this update from JetStack repository also. So now let's validate this, okay, which we have done. Okay, this repository which we have added. Okay, so you can see it's validating that, because we need to implement the certificates to our application. Okay, and earlier, as we saw that in the data, when we were installing the MongoDB, we used the Helm command, Helm install MongoDB, and the namespace for database we gave the ratings app. And for this certificate, I have just created a new namespace at manager, and so in this I'm going to install the certificate manager in the same namespace, and versions I'm passing, and the image JetStack's certificate manager. So I'm going to install this, and it's going to take a small time to install this, to install the image of the certificate issuing. Okay, and you can see its certificate manager has been deployed successfully. Okay, and you can also see, in order to begin issuing certificates, you will need to set up a cluster issuer. So now we have certificate manager deployed, but to issue certificates so that we can get, in other websites, if you see that it's okay, this symbol is coming, that it's a secure connection. Okay, connection. So to get this kind of, we need to create a cluster issuer which will be issuing our certificates. So before that, just verify this pod for the certificate manager. So you can see we have this pods available and status is running. Okay, so now, as in earlier, you see that we need to set up a cluster issuer. So I'm going to deploy a cluster issuer, and to do that, I'm simply going to create a manifest file, cluster issuer.yaml, and in the manifest file, I'm going to pass the values that kind is cluster issuer, and name, I'm going to give it name. So the kind is, now you can see cluster issuer. So till now we have seen like deployment, service, ingress, and this is a new kind, like cluster issuer. And I'm going to name it let's encrypt. So let's encrypt is a repository, non-profit organization for issuing certificates. So you can change here your email, like to receive these certificates, or if your organization, you need to replace your email. So I've just added my email address and private secret name. Let's encrypt. And see, here is the catch. HTTP. I'm using the Ingress class nginx earlier. So nginx we have already installed Ingress nginx. So that's what I'm using here. And again, just save it and close the editor. And again, we just need to apply this certificate to the kubectl. Kubectl apply, and you can see cluster issuer set manager. Let's encrypt created. So now we have created, and what we now need to do, we need to enable this certificate in our website, in our app. So to do that, we are just going to edit this ratings web ingress YAML, okay, using the same code editor. So we will need to edit this YAML file, and we are now here. You just have seen that we used Ingress, ratings web Ingress. We don't have any certificate manager here, but what we are going to do it now, we are going to use, you can see the host is same TLS. I just need to update the IP address here from the IP which I got, and you can see the paths are backend ratings web is still the app is same. And we have issued now annotation that cluster issuer, that you can see cert manager cluster issuer. Let's encrypt. So I'm using that. So I'm going to paste this script in this file, and I'm going to replace my IP which I got from this app. Okay. So my IP, current IP, my application is running on this IP. So I'm going to replace this IP here. Okay. And similarly in this also rules section, I'm going to replace my current IP. Okay. And that's it. For let's save it and again apply this file. So I'm just going to apply again to this. So you can see the ratings web ingress configured. Okay, and now let's verify certificate ratings app. Okay, so we have seen that, okay, this is created, generated new private key, created new certificate. Okay, so we have gotten a new certificate. Okay, so now let's verify our application with this URL that this is. So now this should work with HTTPS and this. Okay, so earlier this was not working, now it should work. Let's see. Now we are using HTTPS. Okay, because we have deployed our certificate manager to the website, so it should be up. And we should be able to view it, but it's not loading. Let me do one thing. Let me open a incognito window and let me try here. Front end IP it's same. Okay, let's try if it's working here. So let's see if it's loads or not. I guess it's not loading. We have deployed the ingress rule and we have got the message that we have the certificate. Okay, region in progress. So you can see again the status. What's the status in this? So set kind certificate, kind name true, and status false, region waiting for certificate request to complete. So I guess okay, it's taking time to generate a certificate, that's why this is not loading. Waiting for certificate request ratings website to complete. We have got this certificate, but it's waiting for the to get the certificate request to complete. So it's still waiting for that. That's why when I am checking the website, it's not loading. Let me check again if the status is okay. It's still waiting. I don't know why. This is just waiting for the certificates. It's not able to get the certificates. And because of that, our website is not loading. Our application is not loading. But don't worry. I mean, it will be up. It should. If you are when you will follow along, you can see. And if you got an issue, you can connect with me, like why it's failing. Okay. So okay, let's move ahead. We can test the applications and see. I mean, if application should work, but since it's not loading, it's not an issue. We should move ahead with our next thing. So at this stage, we should get our HTTPS like a URL, HTTPS front end with the URL. Okay. So the next thing which I explained that in the agenda that we will be monitoring our application. So to monitor application, we need to create a log analytics in our Azure space. So to monitor this, I'm going to create a workspace for the monitoring, and let's give it. And then I'm going to create create a resource for this name. So to create that, I'm going to issue the same command like same Azure AG resource create resource type that Microsoft Operations Insight, because I'm for monitoring it comes under operational insights workspace, and the name is name passed workspace, which I just got from here. And then the resource group, I'm creating this under the same resource group, that AKS workshop. The location is same. At the start, I assigned this location that each to use region, and the properties. Okay. So this is going to create a resource. So you can see HTUS name AKS workshop and resource group this. So this is being created. And now let's monitor. I enable this monitoring add-on. So to enable this, I need to provide the resource ID of my workspace. So for that, I'm going to find the resource ID. Like I'm going to get that resource workspace ID in a variable that is workspace ID. So this, if now I echo workspace ID, workspace and id. You can see I have got this value. Okay, so with this value I'm going to enable the add-on to monitor my applications in the cluster. So you can see the command AGAKS enable add-on resource group, the same name AKS workshop, name AKS, name of the cluster. I passed the AKS cluster name, add-ons. So what add-on am I adding? That is monitoring, and workspace resource ID, which I just fetched in this variable. So I have passed this. Okay, so I'm going to enable this add-on. Okay, so once this is done, I can inspect these event logs and cluster health in my portal. So on the portal itself, I'm going to monitor this from this monitor tag. You see, go to the monitor and you can see we have this monitor. Okay, and in this we can see Insights Hub, and in Insight Hub we can see the containers health, because we are going to monitor the containers. Okay, so saying that monitored cluster, is there any cluster coming? Monitored cluster, you can see, okay, this is a different cluster which I created earlier. Okay, I guess, okay, it's still running. Let's wait for this to add the add-on so that we can monitor our these clusters, this cluster which I earlier created. So you can see in the monitor section we have a new, we have a cluster. So in this way we can monitor the health of our clusters in the monitor section. So till now, we have deployed our application. Our application is up and running on the to the customers, and we have included the SSL TLS certificate using the certificate manager, and we've also enabled the monitoring. And you can see we have got the response in the JSON format. So let me refresh this and see if that's coming. I guess it's not coming. Maybe my, okay, this was from my earlier subscription. It's not coming. I need to check why it's not coming. Okay, so that's how you can monitor, add the enable monitoring section for your app, and we can inspect the same in our Azure portal. So the rest part is like we will be configuring RBAC. RBAC is role-based access control policy, so that like when we are working in the teams, so maybe other team wants to inspect the data, the live log data or something, so we can configure this RBAC role-based access to enable live log data, like which team can access the data and which teams cannot access. So on the basis of roles, we can create a policy, role-based access policy, and with that we can enable the teams to view the live log data. So for that also, in the same way like we have seen, we need to create a manifest file, log reader rbac.yaml, and in that if you see the kind is cluster role. So currently, till now if you see, we have seen the deployment, we have seen the service, we have seen the ingress, and we have seen cluster issuer. And now since it's a kind of role based, we are assigning some role. So the kind is cluster role, and this name is container health, log reader. So because we want to enable different teams to read the data, so that's what the name is, like container health log reader. So with this script, you can create a role based access policy and apply this. And again, to view the live containers log, again you just need to go to this portal, and then you just need to look for the insight sub. Where is that? Just a minute. Monitor, and in that left pane we just need to go to the inside hubs and look for the containers. Okay, because our application is running in containers, so we need to monitor the containers health. And let's see, monitored cluster. Oh, my current cluster is not coming. Let's see if I environment all and refresh this. My current cluster is not being added. I don't know. This is a Spring Boot app which I developed earlier, so that's only coming. And my current, it's okay. There may be some issue with the add-ons. That's why it's not coming. But you will see your cluster in this section, so that you can monitor this. So we have seen the next section is to scale your application. So to scale your application, you can create a horizontal pod auto scaler. I mean, so scaling is done like when you need the scale. If your application traffic grows, so much, and in that case what you need to do, you don't want that your application goes down or users face slowness. So in that case you need to create some auto scaling, so that you don't have to create look for the like scaling and all. So what you can do, you can create a horizontal pod auto scaler. And horizontal pod scaler is a controller. You can see that a controller is Kubernetes control loop that allows Kubernetes controller manager, that is the control plane, to query response resource usage. What it does, it queries the resources usage on the nodes, and it checks that okay, if it needs the auto scaling or not. So when you for to do that in the same way, because we are just following with the scripts, so we can create a manifest file, ratings API HPA, that is horizontal pod auto scaler .yaml, and we can give the, you can see the script is same. We can give the kind of horizontal pod auto scaler name. We are going to same ratings API, and scale target reference. If you see that what here is the main thing, like minimum replica, that the number of minimum replica should be available as 1, and the max replica, like if the when the application needs to scaling, so max replicas we are giving 10, so that if the utilization is goes above like 30, the it will auto generate the auto create a new pod. Okay, and we just need to apply this, and this will, we can do a load test with the uh, image. We have some methods available, this artillery image available, which we can use to test the load of our application. So you can follow along with this. You have the access to this notebook, and you can follow along. If you face any issue, you can connect with me and we can check it if you have any issues at any point. Okay, so with this you can create the all auto scaling of your application. And the last part, what you need to do is, you need to like because when you are working, you are exploring this, You don't want that you incur the cost, because the Microsoft Azure Kubernetes, you will be charged for the nodes. So if you have created nodes, then you will be charged. So after you have completed this exercise, you want to clean up all the resources. So to clean up all the resources, just on the Azure portal, if you see on the Azure portal, you just go to, and you just go to the this resource group. That's why, you just need to delete this resource group, and with this deletion of, you can see all the services, container insights, that the monitoring, workspace, and log analytics, containers, cluster, and vnet, that is virtual net, container registry. You just need to delete this resource, and all the resources will be deleted, so that you don't miss any other resource or service which keep on running, and you may accidentally be charged. So you uh, keep this Azure AKS workshop resource and names unique in all the services which you create, and at last, after completing, you just delete this resource, and this will be deleted from your subscription, and it's done. So that was all about from my side, for the applications. Now I just want to share you to for the better learning resources. You can follow this continued learning like Azure Kubernetes Service documentation on the Microsoft, and you have the sample codes available on the Microsoft GitHub repo, that is Kubernetes learning path. You can also take the 50 days from zero to hero with Kubernetes learning challenge. It's a really great challenge. If you follow this 50 days challenge, you will become a master of Kubernetes. You will get how the Kubernetes works and everything. So I would suggest that you should follow this Microsoft 50 days from zero to hero Kubernetes learning challenge, and after that you can go for the certifications of Microsoft. From Azure, you can start from Azure fundamentals and then go on to the expert levels. That's it, folks. Thank you. So that was all about from my side. And okay, I think Vishwas has disconnected. So thank you so much, guys. Thank you so much for joining me today and exploring this AKS workshop. Uh, do ping us and do connect with the community. And if you need any help at any point, you can always connect with us, and we are happy to help you. Thank you. Thank you so much. Have a good day. Bye.